So you have two data tables, the measured data table and the calculations. The measured is the one that you actually recorded all your data for the lab itself. Now the initial mass of the burner. Yours will vary, of course, but say for example we used 126.22. This was for the methanol. Another one for isopropanol could be 125.92. Again, yours will be different. You also wanted to take the final mass of the burner in grams for both of them. So it's been 125.43 grams. And this one for isopropanol could have been 125.46 grams. You also took the initial temperature of the water in degrees Celsius. Ours could have been 20.5 degrees Celsius for both. Again, yours will be different. And you wanted to take the final temperature of the water. This is after a 20 degrees Celsius change. So we're just hoping that you've taken it off at that time. And then the volume of water in milliliters will stay the same for everyone, as long as you measured it correctly. It ended up being 25 milliliters of water for both. Your second table is for calculations. You have your mass of water in grams, change in temperature, which is your delta T times, or delta T in degrees Celsius, and the mass of the alcohol burned in grams. So the mass of the water in grams would end up being the same as the volume, since the density of water is 1. So we have 25 grams here for methanol and for isopropanol. The change in temperature is your delta T, so all you need to do is subtract your final temperature minus your initial temperature of water. So again, it should be around 20 degrees Celsius. Next, you want to check the mass of the alcohol burned. This is going to be your final mass of the burner minus the initial mass of the burner. Or you can flip-flop as long as you take the absolute value of both. So when you calculate it out, this one could be about 0.76 grams. This one could be about 0.46 grams. So to fill in this table, for the mass of water, this is how much water, or the volume of water that you used in grams. The change in temperature, you take your final temperature minus your initial temperature. And the mass of alcohol burned is your initial mass of burner minus your final mass of burner, or you can flip-flop them as long as you take the absolute value. So moving on to the next page, number 2 asks you to write out the balanced chemical equations for the combustion of both fuels. So find the formula for methanol, and if you look on the page before for the materials, it is listed there. Also add in oxygen, because we did add oxygen as a fuel for it. Go ahead and complete the combustion reaction, which we know CO2 and H2O is produced. The same thing goes for isopropanol. So again, you'll use both methanol and isopropanol for these balanced chemical equations. For number 3, it says use your data to calculate the energy in calories transferred to the water by burning the methanol. In this case, we're changing from in calories to joules, transferred to the water by burning the methanol. So this formula, we need the heat formula. So it's our Q equals mc delta T. We're trying to find Q. We're given the mass of the water. We know what C is by using table B, and delta T is just our change in temperature. And convert this over to Kelvin, which is adding 273 to it. So this is for methanol. For number 4, you'll do the same exact thing for isopropanol. Don't forget, instead of in calories, we want joules. So for number 5, we want to determine the number of calories transferred per gram when you burn 1 gram of methanol. So in case, instead of calories, we want to make sure we put in joules. So in this case, this is going to be for methanol. So take the number received from number 3, which was burning of methanol, and divide that by the number of grams that you obtained of methanol burned from the calculations table. Number 6, determine the number, in this case again, don't forget, changes to joules, transferred per gram when you burn 1 gram of isopropanol. So we found out the amount of heat for isopropanol in number 4. Divide this by the amount of isopropanol burned from your calculations table. So for number 7, we want to determine the number of calories transferred per mole of methanol. So take the number of joules per gram found in number 5 for methanol, and multiply that by the molar mass of methanol. Number 8 asks for the molar mass, or says the molar mass of isopropyl alcohol is 60.0 grams per mole. So this time they're giving you the molar mass instead of making you calculate it out. It says determine the number of calories transferred per mole of isopropanol. So again, we'll change calories to joules. And it's the same exact question as number 7. You're going to multiply the value of joules of isopropyl alcohol, or isopropanol, times the molar mass. In this case, they're giving it to you, which is 60.0 grams per mole. So make sure all of your units cancel and circle your final answer for every question.